I'm trying to develop a keyboard receiver for Pong, and here I'm testing it. So I've created the code to do the receiving. I send it a pulse that says, get me one key. It outputs the key into a probe and then never does it again. There's no loop. We'll watch a run of this. We'll just call make. When all the stuff up here ends, I can type in a character and I'll type in Q. And here we've got a probe showing us that the letter Q is typed. It's returned as a Python binary character. And then I'll hit Control C and get a Python traceback. We don't care about handling this stuff at the moment. We're just testing to see that the single character worked. So here's the Python code for the keyboard receiver part. We need to set up 4 routines, install the template, instantiate a piece of code from that template, define an event handler, and then a reset handler. In this case, the reset handler does nothing. The event handler says if the incoming port is nothing, we call read single character. Getting a single character using Python on an operating system is an involved process because we have to go through the operating system. So we capture the file descriptor, we capture the old settings, we set to raw mode, we grab one character, and then we reset it back to the normal thing. I'm amazed that this works fast enough to be useful. Setting up the template consists of giving it the template a name and a pointer to the instantiator, and then we call registered component, which basically puts it into a hash table in the kernel. When we load the system, we instantiate each of the parts uniquely for every instance of the part. We have to supply the registry, basically the hash table created of all the templates that we have. We're creating a tree of parts, so we have to track the immediate owner of this part. We are building up a name by concatenating names of the owner with the current part. This is mostly for developing low-level parts. We want to know what the command line argument is. We usually just leave that to be empty. Same deal here. We start by creating a name and gensimming it. So the kernel just assigns a subscript to this and keeps the whole instance unique for this particular instance. Here we would create instance data, but in this particular case, we don't need any. We're just grabbing characters and not saving the state anywhere. We create a leaf node within the system. We give it the unique name. We give it the current owner. We give it the instance data. Then this argument, if we're creating special kinds of parts, again, most of the time we're not really worried about this. And we have to give it the 2 handlers, the handler for events and then the handler when the system wants to reset the part. The handler that we're most interested in here is the message handler. This A data structure is something handled by the kernel. It gets passed in opaquely. You can peel off the instance data from it and so on. We'll do that elsewhere. And we get the current event. And an event is really just a message with a tag in front of it. And the tag is the .port field. And in this case, we're expecting it to be an empty string. If we get that port, then we pull out one character from the keyboard. If we got a character, we send it out the stood out or empty string port. In this case, we're creating a string from the single character, and we have to tag every send with the current message. That's just for tracing purposes. Here's main.py that gets run by @make. We do the usual imports here to get the kernel and the sys. We do a couple of special imports here because we're doing character by character I/O. And here's a bunch of code that sets up character by character I/O for Python. Here's the actual code that we're running in main.py. We initialize the keyboard. Basically, we're just storing the old settings. We call the kernel to get us a hash table of parts and an environment. Given the third argv argument, we install the keyboard receiver, and then we run the system. With the second argument from the make file, it's at make C, there we go. There's the call to the make. This call here converts the pong.drawio file that I showed earlier into pong.drawio.json. It removes a lot of the graphics only rendering information and just leaves the semantically interesting information. And then we run main.py with 3 args. The arg here is nothing. We're going to use the test kbd tab off of the drawio diagram, and we're going to use the pong.drawio.json that was created up here. And then we remove any temp files. We set the terminal back to sane mode, and we declare we're finished. So what's next after this? I think we're going to need to create a decoder part, remove this probe, and put a decoder in here, and have it decode up arrows and down arrows, and I don't know, QA for up and down on the left side, and Control C for a clean exit.